Take a few minutes and warm yourself up. Pause the video. I just have one bit of advice to add on this page, and that is when you're getting slopes that are fractions, you got to remember not to be afraid of the slopes that are fractions, because that's just rise over run. So we actually like slopes that are fractions. They should make sense to us when we're graphing. Here's a graph of what perpendicular lines would look like. Perpendicular lines are lines that do intersect in a special way. They intersect at a 90-degree angle, and that's why you see this little square in the corner there. That means that is a 90-degree angle. Just like we had a special symbol for parallel lines, we also have one for perpendicular lines. And that is a vertical line down and a horizontal line across, indicating the 90-degree angle. I don't have the equations written for the blue line and the red line here, but I will just tell you that slopes of perpendicular lines will be opposite reciprocals. Let's talk about these two words. Opposite, that's important. That means your signs will be different. So if your sign started out as positive in one line, the perpendicular line's slope will be negative. If your line started off with a negative slope, the perpendicular slope will be positive. Let's look at this example back up at the top. I can tell the blue line, its equation was 4y minus 3x equals 8. Well, if I put that in slope-intercept form, I can see that the slope was 3/4. Therefore, knowing that the perpendicular line's slope has to be an opposite reciprocal, I know the sign of the perpendicular slope will be negative. Now, what do I mean by reciprocal? Reciprocal we've practiced before, and that just means you flip your fraction. So flipping the 3/4 from my blue line will give me 4/3. And here is my perpendicular slope of the red line. It'll be a negative 4/3. Practice this idea a little bit on a graphing calculator. We're given again y equals 2x plus 3. Can you graph another line that's perpendicular to it, knowing what you know now about the slopes? Give it a try. Remember, you can use GeoGebra.com to do it, or borrow one of my graphing calculators, but it's really good to see. Here we're asked to find the slope of the perpendicular line. Well, number 1 has a slope of 3/4. So my slope that's perpendicular will be the opposite sign. That means it'll be negative. And then you flip your fraction. So the slope of my perpendicular line will be a negative 4/3. Number 2. My slope is 2, and you need to understand that that really means that I have the fraction 2 over 1. Every whole number is really over 1. So my perpendicular line will be the opposite sign, so negative, and the reciprocal of the fraction, which is 1/2. You try number 3. Did you get 1/3? It'll be a positive because I have to take the opposite sign, and the reciprocal of 3/1 is 1/3. Example 2 asks us if the two lines are truly perpendicular. Again, it's all about the slopes. My slope of my first line is a -2/3. Is 3/2 the opposite reciprocal of -2/3? Let's look at example 2. My slope of my top line is -3. The slope of the second one is -1/3. Are those fractions opposite reciprocals? Well, they're reciprocals because 3 and 1/3 are reciprocals, but they are not opposite signs. So these will not be perpendicular when you graph them. You try these two. Are these lines perpendicular to each other? Pause the video. The last part of our video will be writing equations for lines that are perpendicular to each other. Looking at example number 1, we have the equation y equals 3x plus 7. The perpendicular slope to 3 will be the opposite sign and reciprocal fraction. The point it's going to go through is 0, 0. So again, we're going to write it in point-slope form. Remember, point-slope form always has that skeletal structure, and we need to fill in the slope and then the point that we're given, and we're done. You can leave the zeros or you can take them out. If you wanted to take them out, your equation would look like this. And you can truly see that these slopes are opposite reciprocals. Let's do it again with number 2. But number 2 is a little more involved because we are not in slope-intercept form right now. And if I'm not in slope-intercept form, I cannot tell what my slope truly is. So we need to add the 10x to both sides. And then divide by 8. Cleaning it up, I use my first fraction here, which is 10/8. Well, that can be reduced, and we should reduce it to 5/4 x. And then that 3/8, just leave because there's nothing we can do about it. But I do see my fraction for my slope is 5/4. So you know your perpendicular slope is going to be 4/5, but it's going to be negative. So using the slope you found for the perpendicular line and the point you're given, just write it in point-slope form. Y minus 12 equals the slope times the quantity x minus 15. You've just written the equation for the perpendicular line. One last example for you to try. Given this equation, can you write the line that's perpendicular to it that goes through the point 3, -8? Again, if you ever wanted to check these, you could graph them on a graphing calculator or by hand to see that these truly are perpendicular. If you're using a graphing calculator, you would need to convert this form into slope-intercept form. And if we want practice doing it, I'll show you how to do it right now. So taking your line in point-slope form, my first job would be to distribute the positive 1/2. So I would get 1/2 x minus 3/2, and go ahead and leave the fraction. On the left side, we still have y plus 8. So I would have to subtract 8 from both sides, leaving me with y equals 1/2 x, and then I have -3/2 minus 8. Either deal with that on your calculator or get the common denominator so that you can subtract these two numbers. The common denominator would be 2, and so I'd have to multiply the top and the bottom by 2. Rewriting this, I'll go up here, you get y equals 1/2 x minus the 3/2 minus 16/2. -3 minus 16 is a -19/2, and go ahead and leave it like that. Your calculator can handle it, or GeoGebra can handle it, but I guess if you are doing it by hand, you would want to take that 19/2 and divide it by, or make it a decimal, and so that would be your 9.5, which would be your y-intercept. Alright, well now you know everything there is to know about parallel and perpendicular lines. Good job.